In this tutorial, we are going to create a simple hex grid movement system in Unity by first implementing a way to represent a grid of hex tiles in our code. Next, by using a breadth-first search algorithm, we are going to find character movement range and find a path between 2 points on our map. Hi, I'm Peter and welcome to Sunny Valley Studio Tutorials. First, the asset that I will be using are KaiKit Medieval Builder Pack, and the link will be in the description to the itch.io page where you can download those. There will also be a link to a starter project for my patrons if you want to follow along with this tutorial. I have created a new universal rendering pipeline project using Unity 2021, and I have prepared a hex prefab. Now this is simply a game object with a mesh collider on it. I am using one of the meshes from the asset pack to represent the collider so that we can click on it and select it. And I have set it to be convex just for efficiency purposes. Now it contains two children, main and props. This is only because of how the KaiKit assets are created. They are split into objects and into tiles. I have created prefabs from those, so ground prefabs, and one of those is hex forest, so I will select it and drag it into the main child object. The hex is placed in Y position 0, and I will only modify the X and Z positions. Now props, you can place here the other elements like bridges and trees and so on. And this is only set to be on position Y equals 1, so that all of those objects will be rendered at the top of the hex. Now I'll move the camera a bit higher to be able to see this hex. Okay, great. So now, what I will want to do is, I will want to place the hexes near each other. So now I will want to focus from the Y-axis perspective, and I will select the orthographic camera so that I can place my hexes in our map. And I will Ctrl-D to duplicate this one hex, and as you can see we are not exactly moving with the right increment, so that we can easily place those hexes around our map. So what I will do is delete this hex and go to Edit and Gridded Snap Settings, and I will want to move in increment of 1 on X-axis, and I will want to set the Z value as well. So I will check this symbol to free it from being constrained on all axes. And on Z-axis I will set the parameter to be 1.73, since I have found this value to be working well. I will close this. Now if I select this hex, Ctrl-D to duplicate it, I will be moving 1 on X-axis, and if I duplicate it again and move it up, I will be moving by 1.73, as you can see in the transform settings, and I can fit those hexes quite nicely. I will create a new empty object called ground, and I will reset its transform. I will move those hexes into this ground, and now I can create a simple map. Okay, we have our simple map, and I will set the camera to be orthographic just for the sake of being able to better see the map, and I will zoom out, so set the size of the camera to be something like 7.55. Okay, great, this should work well. Now we have all those hex tiles in our map, but to actually work with those in the code to run some algorithms on those, we need to save those tiles, those hex tiles, into some sort of a data structure in our scripts. Now, if you were working with square tiles, we would simply assign to each square a int coordinate value on X and Y, such as 0, 0, 0, 1, 1, 1, and 1, 0, and this would allow us to easily find the neighbors around each square tile, as well as to store those square tiles, because we can easily compare integer values. Now in our hex map, we have for the row with Z0 coordinates like 4, 6, and 2 on X's, but the row above have 3, so odd numbers, and Z's are with increment of 1.73. So this is an issue when we want to convert all of those to the correct coordinate system. What we know so far is that the offset between x's in a row is about 2, while on Z's, since we are working in a 3D environment, is 1.73. So we are going to use those values to convert those position values into integers. To perform the conversion from the position of the transform to a separate coordinate system, I have created this hex coordinates script. I will store here a public static float offsets on x, y, and z. I know that the offset on x is 2, on y is 1 because there is no offset, and on z it is 1.73. And those I will want to use to convert the position of the hex into a separate coordinate system of integers. I will store it as a private vector3 int offset coordinates, and I will calculate them in the awake by calling offset coordinates equals, and I will create a new method called convert position to offset, passing it transform.position. I will right click quick actions and generate this method, and the basic idea would be to simply divide each position by the offset and round it to an int, and we should be good to go, right? Not exactly, because even rows have x values that is dividable by 2, while odd rows have the value 1, 3, 5, so this is an odd value, and we will have to deal with halves. So as you can see, we are going to end up with inconsistent columns for different hexes on our grid. So we cannot really use round to int when we have those hexes in the row above and in the row below that has odd x value. Now, of course, if you would have those hexes rotated by 90 degrees, the problem would be not in the rows but in the columns, so we would have something like this. But we need to work with our x, so this is a row where the z is 0 and the x's are divisible by 2. But in those odd rows, the x's will leave us with a half, and this will be the cause why we are going to have those errors when assigning different hexes to different columns. So there are two solutions. We can either floor to int all the x coordinates that we get from division of x value by the offset, or we can sail to int. I will select the second option to sail to int the x values so that my columns are consistent. So in our code, instead of rounding to int the x value, we are going to tail to int. Now again, if your hexes were rotated by 90 degrees, you would have this calculation on z's. Okay, so if we save our script and go back to Unity, since my hexes are prefabs, I can simply open a prefab and assign the hex coordinates to a prefab, save the prefab, and now if we press play, we will see that our hex coordinate script has calculated the values. So for position 0, 0, 0, it is 0, 0, 0. For the one to the right, it will be 1, 0, 0, but the position is 2, 0, 0. Now one above, there will be an issue when selecting it because this will select the child object. The one above will have 1, 0, 1, and the position is 1, 0, 1.73. Now we are going to explore more about this, but now let's fix this issue where we want to select a hex in our scene view, but we are selecting the child object. So for this, I will create a new script called hex. Okay. And this will be the main script for each hex, and this will contain all the references to different scripts on our hex, so to highlight that we are going to implement later on, but also to our hex coordinates. So for now, what I will have here is a private hex coordinates, and I will have a public vector3 int property called hexcards, and this will simply call our hex coordinates.get hexcards. And since we do not have this method, I will right click on it, quick action, and generate this method. And in this method, if I go to the definition of it, I will simply return our offset coordinates. And this is because we are going to later on implement a different set of coordinates that will make it easier for us to implement different algorithms, since the offset coordinate system isn't perfect. But for now, we will continue with it because I want to show you why it is not perfect. So back in our hex, so now we are going to be able to get the hex coordinates from our hex class. We haven't assigned this hex coordinates, so we are going to create awake here. And in the awake, we are going to assign to our hex coordinates equals get component of type hex coordinates, because we know this is on our prefab. Now also we want to add an attribute above our class SelectionBase. As you read in the documentation, this attribute added to the script marks the game object as SelectionBase object for our scene view picking. So basically we are going to always select the parent game object and not the child as we did so far. Okay, with all this done, let's save this hex script. Let's go back to Unity. All we need to do is stop playing the game, select one of those hexes and open the prefab. And now I want to assign the hex script to it as well. And this is it. Let's save the prefab. So now we have int coordinates that we can use to save the references to our hexes. Now we need to have a data structure that will store those references. And for this I will create a new script that will be called Hex Grid. Here in this script I will store all the hex tiles, and there are many possibilities to store those references. One is a simple dictionary, and since we already have a vector3 int coordinates, we are going to store it as a key, and the value will be our hex script reference, and I'm going to call this dictionary hextileDict. Now what we will want to do is in the start, we are going to loop for each. We are going to find a hex, let's call it hex, and we are going to find objects of type, and I'm going to pass hex. Okay, and this will only run once at the start of our game, and we are going to pass to our hextileDict and we are going to open square brackets hex.hexChords, and we are going to assign to it our hex. And this way we have saved our hexes to our dictionary. Now beside getting all those hex tiles assigned to our dictionary, we will want to have a method that will be able to get the hex from our vector3 int, and for this what we are going to do is assign hex result equals null, and we are going to use the try get value method from a dictionary, and if the dictionary contains it, it will return it. If it doesn't contain it, the hex result will stay null, and we are going to simply return null. Now, the whole point of storing those hex tiles inside our dictionary is to be able to access the neighbors of a hex when we select it. For this, and to help us with this task, we are going to create a new public static class called directions, which will simply store a list of vector3s, so directions, to each neighbor. We can create it in the same file as our hex grid. Now, of course, there will be a problem when finding neighbors. Now, if we have a simple square grid, we can simply ask for a neighbor to the right, to the left, up and down, and those directions will work for each square on our square grid. If we were to offset some of those rows, as you can see now, our point 0, 0 is accessing a neighbor slightly to the right when we are asking for the up neighbor, and the neighbor in the below row will be asking for the neighbor slightly to the left. And this is for the even row, so the z value is even. Now, if we want to ask for the same in the odd row, when the z value is odd, we are going to have a different neighbors up and down. Now, our up neighbor will be slightly to the left, compared to the previously when it was slightly to the right, and below it will also be the other way around. So this means that we need to have two different lists, and depending on if we are working with a row that is even or odd, we are going to need to ask for different neighbors. Now the same will be with our hexes. For one hex, those values will be 0, 1, 1, 1 above, and 0, -1, 1, -1 below for the even row. Now if we ask for an odd row, those values will change. Well, actually not all, some of those will be the same, so only two of those values, one up and one down, will be different. So this is -1, -1, and here we had 1 and -1. And again, we are going to also have two lists. Depending if we are working with an even or odd row, we are going to need to use different neighbor directions to get the correct ones from our grid. So this is why our offset coordinates aren't perfect to work with, and in the later videos I will show you a better coordinate system to store those values. For now, let's not worry about it. I'll create those two lists. So those will be public static list of vector3 int, directions offset odd, and directions offset even. So those are two neighbors up. East will be the same for both of those, west will be the same for both of those, and south, so downwards neighbors will be those two. And for the directions offset even, those will be, one of those will be different. So we had here -1, -1, here we have 1, -1, and for up we have -1, 1 in the odd row and 1, 1 in the even row. So those are simply those coordinates, but in x, y, and z form, because we are working in 3D, not 2D space. Last thing that we need to have in the static class is a method that will return us the correct list depending on the z value, because basically odd rows have the z value that is odd and even rows have the z value that is even. And again, if you have those hex tiles rotated 90 degrees, you will be talking about x value. All we do here is check what is the remainder of the division of z divided by 2. If this is 0, then we are working with the even row. If this is 1, we are going to be talking about the odd row. And this is how we are going to get this. All we need to do is to have a method here in our hex grid to get those neighbors. Now I will want to cache the calculated neighbors, so I will create a second dictionary that will contain a vector3 int as the key, so the position of our hex, and a list of vector3 ints, which will be the list of the neighbors. And now, below our getTileAdd, I will create a new method called public list vector3 int getNeighbors4. It will take as a parameter vector3 int hex coordinates, so this will be the position of the hex that we are interested in to get the neighbors for. And we are going to have two checks. If our dictionary doesn't contain this key, we will want to simply return a new list of vector3 ints, so we are not going to return null, but instead we are going to simply return an empty list. Now if our neighbors dict contains this key, we are going to return the cached value. And this is why we have created this dictionary above. Now, if this is not so, we are going to add to our dictionary of neighbors the hex coordinates and a new list. And we are going to loop for each var direction, and this will be a vector3 int. And we are going to get the direction from the list of directions, passing the hex coordinates.z value to decide if we are talking about the odd or even row. For each of those directions, we're going to simply check if our hex tile dict contains this hex coordinates plus this direction. If it does, we're going to add this hex to our list of neighbors by calling hex tile neighbors dict, passing the hex coordinates as the key, and we are going to add to this list that we have created here the hex coordinates plus this direction. So this way we are going to create a list of neighbors for this specific hex. And we are going to return this list by again calling our hex tile neighbors dict that we have filled in here in this for loop, and we are going to pass this key. Now to test our system, first we can simply, after we get all the hexes into our grid, we can create an additional code, list of vector3 int neighbors equals getNeighbors4, so our new method, and we are going to pass vector3 int 0, 0, 0, because I know that this is the first hex that I have created. I will debug.log neighbors for 0, 0, 0 r, and I will loop for each vector3 int neighbor position in our neighbors list, and I will debug.log those neighbors. Let's save our hex grid or file and save all. Great. Now if your hex parents have this hex coordinates and hex script on it, we can see, as you can see, if we select in the scene view, we are always going to select the parent and not the child object of this main child transform. Now we need to create our hex grid, and for this we are going to right click, create a new game object called hex grid, and let's reset its transform, and let's add here our hex grid script. Now if we press play, we should see that for this 0, 0, 0 positioned hex, we should have console logs for its neighbors. If we select the neighbor above, it indeed has 1, 0, 1 coordinates. The neighbor on the right, it has 1, 0, 0, and it is correct. Neighbor below to the right, it has 1, 0, minus 1, it is correct, and the last neighbor is 0, 0, minus 1, which is correct. Okay, we know that our system works, but this isn't very visual, so we cannot really check if those neighbors are correct for any other hex on our map. So in the next video, we are going to create a system that will allow us to click on a hex and for it to highlight the neighbors around it. Okay, see you in the next video.